All right, welcome everyone. My name is Anna Prakash. I work at Intel as an engineer. I've been at Intel for 17 years, and I'm also very passionate about education, especially STEM education. And I have a nonprofit called Education Empowers. We bring STEM programs for schools. So thank you for joining today's event. Before we start, I want to thank our sponsors and supporters, especially Intel volunteers and Intel Foundation. Because of their support, we are able to bring these programs to children in the community. We bring a lot of robotics programs, drone programs, Arduino, Raspberry Pi based programs, and we also do virtual robotics programs. So, big thank you to our Intel volunteers and sponsors for their support. A couple of lines about Education Empowers. Our mission is to inspire and promote STEM education. We focus on robotics, coding, STEM, STEAM, and sustainability education to instill passion for learning and discovery, confidence to enable scholarships and career opportunities. And the way we do it is by partnership. We partner up with local industries like Intel, nonprofits, Boys and Girls Clubs, ICANN, local schools, Girl Scouts, and help create after school STEM clubs, robotics clubs, coding clubs, drone clubs, maker clubs, and First Lego League and VEX robotics teams, and we promote year-round STEM education. Our programs are currently in more than 100 locations in Arizona, and you can get more information of what we do by visiting our website educationempowers.org. So with that said, I would like to invite today's speaker. She is Sonali Bhat. She is a software engineer at Intel. She got her master's degree in computer science from Arizona State University, and she lives in Oregon. She loves to volunteer and making an impact in the community, and she's always there supporting Education Empowers programs in Oregon. They have programs. Our programs are in pretty much all of the Boys and Girls Clubs, and also starting in some schools in Oregon. So she's very passionate about promoting education for children. She's originally from India, but she lives in Oregon right now. So with that said, I'm going to stop sharing my screen and invite Sonali to share her STEM journey. Thank you, Sonali, for joining us today.
Thank you, Anna. All right. So, hi, everyone. I'm Sonali Bhat, and I'm here to share my STEM journey. The agenda for today is I'm going to go over what Intel really does, and then go over my STEM journey, then go a little bit into different engineering domains, and lastly, give a little bit of introduction about artificial intelligence. I am sure every one of you have heard the name of the company Intel. Let me play a video so that you get some more idea about what Intel really does.
The world is producing data at an unprecedented rate, faster than our ability to analyze and understand it. To move, store, and compute all of this data requires incredible processing power. From the blazing speeds of our devices to blazing trails within AI, Intel builds chips that are at the heart of nearly everything. Within every Intel chip manufacturing facility across the globe, innovators are pushing the limits of science and literally rearranging atoms to create groundbreaking technology. This strong silicon foundation is what gives each Intel chip limitless potential. At the heart of all modern electronics, the transistor is a tiny switch, 10,000 times smaller than a human hair, that controls the flow of electrons through a circuit. To build a processor, billions of transistors are packed into an area no larger than a fingernail. It's one of mankind's most complex feats, and a remarkable achievement that Intel has essentially doubled transistor density in every new generation of processors. The process begins when silicon-rich sand is melted and cooled, forming a solid, which is then sliced into wafers. Once inside an Intel fab, the raw wafers begin their long journey through an incredibly complex process. They're loaded into front-opening unified pods, or FOUPs, which travel hundreds of miles along Intel's automated superhighway, going from tool to tool, as processors are painstakingly built up on each wafer. The wafer first goes through a series of important steps, such as photolithography, ion implantation, and etching, that prepare it for the critical transistor formation process. Intel was the first to manufacture three-dimensional transistors called FinFETs. FinFET construction requires first building a channel in the form of a fin. Intel has devised several innovations to overcome fundamental barriers to continued transistor scaling. One such innovation is a breakthrough fabrication method called gate last. It involves building, then removing a temporary gate in order to precisely place the dielectric material and metal gate. This allows for the gate to wrap around the fin and control the flow of electrons through the channel. Another invention moves the transistor contact directly over the active gate. To accomplish this, the gate material is recessed and then filled with insulating dielectric material to prevent the creation of a short circuit. Next, the dielectric near the gate is etched, filled with metal, recessed, and capped to allow a novel self-aligning process that enables the high-density contact geometries. Now, the dielectrics are etched selectively to expose only the desired part to connect to the first metal lines. This is done through an innovative via etch and deposition scheme, allowing contact over active gate to happen. Finally, dozens of layers of metal interconnect lines are added to complete the circuit. After more than 1,000 of these complex steps, the wafers are finally prepared for singulation and packaging. Innovative processor packaging has become a critical feature of advanced computing architecture. 2D and 3D packaging technologies are enabling new device form factors and additional boosts in performance and energy efficiency. Testing of the final product ensures that every chip exceeds our performance and quality standards. In addition to adding more performance and features with each new processor generation, Intel's integrated design and manufacturing capabilities have enabled humanity to innovate game-changing technologies that impact nearly every facet of modern life. Intel keeps powering the world. At the same time, we're powered by you, the makers, the dreamers, the doers, the people who share in our history of making the world smarter, faster, and more connected.
Wow, I know that was a lot of information, but at the same time, it's so fascinating to see what Intel does for the world. I'm sure, given at least the last year's situation, Intel has made a big impact on the world. I don't think people could have worked from home or attended schools from home had it not been for Intel processors. I'm really honored, and actually I'm proud to be a part of Intel. It helps me make a big impact on the community. A little bit about me. I'm a software engineer at Intel. I mostly code. I solve problems by writing code usually and working on some cool natural language translations. So what kind of problems do I solve? You saw in the video that when a processor is manufactured, it goes through multiple steps. The job that I have is to collect data at every single step to see if the measurements of the wafer was as expected. It's a lot of data that's coming from the factories. It's a big challenge to bring them all to one place so that some person who's not a software engineer who wants to look at the data and say, hey, are all the current processors working as expected? Is the quality good? To do that, there should be software engineers who bring the data in. And today, without data, I don't think any of the companies exist. Rather, data is like the current oil. You can make a lot of analysis using data. And the second part that I was speaking about was natural language translations. I'm sure you people have used Alexa or Google Home. You give it some commands in your language and it understands and gets you the answers. That's what natural language processing is about. Taking in natural language from the humans, understanding it, and giving the results back. Some of my hobbies are I really like cycling. I love reading books. I love dancing. I also love learning new languages. The current language that I'm learning is Spanish. I'm originally from India, the southern part of India. After my undergraduation, I started working there. But then I realized I wanted to learn more. I wasn't really happy with what I was working on. And that's when I decided I want to pursue my master's. And I started researching about all the countries that I can go to pursue my master's. And United States was one of the best countries for computer science. I ended up taking I ended up going to Arizona State. After my graduation, I got a job at Intel in Oregon, so I moved to Oregon. What was my motivation to be a software engineer? I loved math right from my young ages, and I really enjoyed solving problems. I was also very curious, and I really liked science a lot as compared to maybe history or any other course. So I kind of knew that science is where I want to go. Is that's the direction that I want to go in, but I didn't really know what exactly do I want to be. The other big motivation for me was my father. My father was a mechanical engineer. He had a cashew processing industry. The cashew that you consume now is not exactly the form that it is in naturally. On the right hand side, you see a picture of what a cashew fruit looks like. There's a fruit and there's a cashew apple. There's the kernel with the shell, and there's like a thin skin on top of it. The processing that happens is after it's harvested, it is sun dried. Once it's dried, you put it in big steamers, steam it so that the shell pops off. Once the shell is out, there's a thin layer of skin, just like you see on almonds. It's hard to peel it off directly. And then there's the grading process where, based on the quality, you kind of segregate it and then package it and sell it. Growing up, I used to see all this. I used to go to the factory and see all these steps, but most of them were manual. I wondered how hard is it to automate the steaming process, the shelling process. Why should people sit and do it? Rather, they could do something better in their lives. And that's the question that I asked my dad. And he said, why don't you why don't you be an engineer and you come and solve these kind of problems? So was the journey easy for me? Not really. So what were my challenges? Just like I mentioned to you earlier, I knew that science was something that I liked, but I didn't know what is the right engineering domain for me. You guys are lucky because you get exposure to coding and things when you're at a really young age. So you can make a sensible decision as to, do you really like computer science versus electrical? That was a struggle that I had. The second was I had struggled with self-confidence. I always used to question myself, will I be able to do this? Really, is engineering for me? But then with practice and with getting better at it, I think I gained my self-confidence. The other problem that I had is fear of public speaking. I was not a person who was comfortable speaking in front of people, just like I'm doing now. The way I overcame that is by joining clubs like Toastmasters so that I feel comfortable to talk in front of people. Being a software engineer doesn't require you to speak publicly every time, but once you have an engineering solution, you'll have to present it to people. So you have to be good at presentation. And the last thing was my undergrad school wasn't that great. My fun, even though the school that I went to had some good courses, some were not that great. But the good thing about this is, even if my lecturers weren't or professors weren't that great, there were enough resources for me to go and look at like books or online courses to get my fundamentals right. My key takeaway from this is dream big, believe in yourself, work hard, stay focused, and surround yourself with good people. Some people who are ambitious, who can drive you in the same direction as them. And if you can dream it, you can do it. What are some of the advantages of being in STEM? You have a lot of opportunities to solve really challenging and life-changing problems. You can make a big impact on the world. Of course, there's a good salary that comes with such jobs. There are a lot of job opportunities. There are so many companies today that you will never ever find yourself with less opportunities as compared to many other professions. There you get a chance to learn new things, or rather you have to learn new things because technology changes so fast that you have to keep up. And if you're someone like me who gets bored after 2 years of working on something and you want to learn something new, engineering is the field to be in. And there are lots of opportunities to grow in the industry. Say you join as a software engineer in a company, and after a few years, you realize that maybe I don't want to code a lot. Do I have any other opportunities here? You could be a project manager where you say, these are the things that I want in my product, and people can follow it. So you kind of set the direction as to what the product should be. Or you can be an engineering manager where you can lead people, you can set goals for people, help people grow. Even in the engineering field, you have so many opportunities. And also, one thing that I can tell you is, given the past year where COVID has affected a lot of people, I don't see that tech jobs were affected that much because technology is so essential now that people cannot function without technology that easily. Do you have to be an expert in math and science to be an engineer? Not really. You need to know your fundamentals well. You also need to know how to transfer knowledge from one field to another. For example, at Intel, there are electrical engineers designing things, and there are software engineers writing software to make that whole product work. People should be able to know how to transfer knowledge between one domain to another. And the last point is something that I really want to stress on, that teamwork is really essential in the tech field. It's all about teamwork, we before me. And I want to focus on that because some companies, even if you're really smart and you're extraordinary coding skills, won't hire you if you are not a good team player. That's a really essential thing. Is it amazing after you become a software engineer or any engineer for that matter? No, you have to continuously learn and be relevant. Just like I mentioned, some software that was written 20 years ago may not be even relevant at this point. The technologies change so fast that you have to learn new things. But companies like Intel provides you enough resources to keep yourself updated. There might be challenges faced not because of your skills, but maybe because of the environment around you, like the COVID situation. So you have to be resilient in such situations and know how to face it. And also, you need to know how to have a balance between your work and life. It's easy to get absorbed into work and forget that you have other priorities too, like your family or your hobbies or things. So you need to learn how to have a good work life balance. Here are some of the engineering domains. I'm sure many of you know about these. Electrical engineers are mostly people who design the hardware of the computers, laptops, or phones. Chemical engineers use their passion for chemical study and manufacture a lot of things like paper. Civil engineers help build roads, houses, build bridges for you. Mechanical engineers build cars, machines. There's a lot of things that are done in the aerospace field. Biomedical engineering is all about designing or creating machines for the medical field, like scanning machines, artificial hips. Software engineers like me write softwares like apps that you use, video games, self-driving cars, write all the software for that. I just heard that you guys will be using Python. That's what I use for my work at Intel. And data scientists are people who make machines really smart using data. Let me go over a little bit about artificial intelligence. Are machines really smart? Are they smarter than humans? Not really. But what are they good at? They're really good at computations, right? Can you make use of that power and make them smarter? You can give a machine enough data to make some correlations. For example, if it's a self-driving car and you show it enough pictures of a stop sign and say that, hey, if you see a stop sign, you're supposed to stop the car. You teach it over and over again, it learns it and it automatically does it. That is what artificial intelligence is, making machines smarter by giving it enough data. Another example that I can give you is I'm sure you get a lot of movie recommendations or even YouTube videos that it says, hey, you watch this, maybe you'll like this too. How does it even do that? It looks at what video you've watched, kind of get the genre that you're interested in, and look at other videos which are similar to this and show it to you saying, maybe you like this. These are all applications of artificial intelligence. One is self-driving cars, robots like Roomba, the Alexa, Siri, all these assistants, movie recommendations, Google Maps. It recommends one path versus the other based on traffic. There are also chatbots which you can talk to. You ask them a question, you get an answer in that domain. That's what I was talking about earlier when when I mentioned natural language processing. You type in a text and it knows. So, like, a good example is Google search. You type in some words, it gets you the documents. The way it does it, it takes all the words that you typed in, looks at its corpus, and looks at all the documents that kind of consist that have that word and give it back to you. Isn't this fascinating? This is a really amazing field to be in, and I enjoy it a lot. That's all I had for you guys. Any questions?
Thank you, Sonali. Oh, what a great, inspiring story. I get inspired every time you share your journey, and I hope it's the same with the students who are watching this. If you can, yeah. So let me see if students have any questions. Hi, Mrs. Hong. Can you type it into the chat, or can you also ask questions?
Anyone have a question? Um, well, the student don't have questions, but I do.
Okay.
So thank you for sharing your journey. And I like that you list all the different types of engineers out there, and and like whether you have to be good at math or science in order to enter the field. My question is, how do you motivate someone that, I mean, I do have children at, my child at home, and yeah, I work with students. I do have, you know, sometime at this age, they said, I don't know what my dream is, or I don't know what I want. So how do you motivate them? And you know that they're good at certain things, and then they could be in STEM and still, you know, say that I don't know what my dream is.
Yeah, I think I have been in that bucket too, where I didn't really know what I wanted to do. I think exposure to these kind of events like the robotics, um, the first Lego League, and all these kind of activities that you have, some coding challenges and such things, kind of give you exposure. And I think as long as you make it more like not just, hey, go and study this and maybe this is what you want to be, rather it's some interactive activity. I think it motivates people to be in that field. Robotics is more like a game, and they're like, hey, I can make this work this way. So maybe that's for me. Or they might be interested in a completely different field too, and they'll realize that when they code, they're like, okay, maybe coding is not really the thing that I want to do. Maybe rather I want to focus on the parts of the robot which moves. Maybe I want to be a mechanical engineer. I think with practice and activities, more exposure will help you.
Thank you. I agree with that as well. Exposure is the key driver, I think, because we work with a lot of children from boys and girls clubs and ICANN, where the children have never even seen a robot or held a robot. But at the end of the year, we see the enthusiasm, the passion build up as they get more exposed. And the other piece also we recommend is having them teach younger children. So volunteering and helping little children who are new to programs learn actually gives them more confidence, and it gives them some reason to stay on the STEM wagon and explore many things that they haven't explored before. So yes, I think exposure and also motivating children to teach younger kids even small things that they know other children. For other children it may be something completely new. I think those two things I found as very helpful, bringing children on board. So in every boys and girls clubs that we work, we start with every year we start with 20 students who have not had previous exposure to any kind of STEM fields. And then by the end of the year, we see them so motivated, they want to come back and do it again. And then we also have the older kids in the Boys and Girls Club teach younger kids through our STEM Ambassador program. So we train them to do that, and that keeps them continuously motivated, continuously learning. And then we try to also bring in industry experts like Sonali, who shares their story, so children get to connect with those role models, and they also understand that, hey, these people come from backgrounds that are not completely engineering backgrounds, right? They continuously learning, they're continuously staying in school. So having that exposure to role models actually is a big plus for these students.
Yeah, to add to that, I think even having joining these kind of clubs, you'll have friends also in similar field, and when you have friends of that sort, I think it will help you move further faster.
Always finding friends that can help solve problems. That's exactly what we do on a daily basis at work. When a problem statement comes up, we immediately pull in a team to brainstorm, and then we share each of our inputs, and then we come up with, these are all potential solutions for this problem. And then we use some kind of fail mode effect analysis, which is way of ranking all these different problems in a prioritize which ones the team has to focus on, what kind of data needs to be collected, so we can solve that problem. So it's all teamwork. So any kind of connections they develop in schools, in clubs, when with mentors, you continue to build on that as they go, and it's going to be help them stay motivated and in the field. Yeah, very true, Sonali. Yeah.
Thank you.
Thank
Thank
you.
you. Any other questions from the students? I'm sure they have questions. Oh, I forgot to mention, Sonali, when the pandemic started, you did some volunteering. You want to share
Yeah.
that with them? I read
Oh,
about it
sure.
on Circuit and newspaper, and I thought it was so impactful.
Yeah, so initially, when the whole pandemic started, I couldn't go anywhere anyway. So I was like, can I help the community in some way? And one thing that I saw was there was a group of people who were trying to go and deliver food, groceries rather, not food, to people in need, like old people or someone with pre-existing conditions who cannot go to the grocery stores to shop. So this bunch of people would go and buy it and deliver it to their house. So I was responsible for coordinating, looking at areas and seeing, hey, are the volunteers who will buy it and are there volunteers who will go and deliver it? So kind of coordinating and trying to make people get all the things that they need.
Awesome. Thank you for sharing that.
Awesome.
Awesome, awesome. Yeah.
Lots of inspiration.
Oh, thank you.
Thank you.
Okay. I think, um, yeah, we don't have any more questions.
All right. Thank you. Thank
Thank
you,
you.
Sonali. Again, appreciate you joining us and
Thank you.
giving us such a fantastic STEM journey session. Thank you. You're welcome to stay with us. We are just going to spend a couple of minutes. Mrs. Hong, do we have a few minutes, like 10 minutes, to go through some of the demos that we do?
Yes, we do.
All right. Thank you. Thank you, Sonali. Talk to you soon.
Thank you.
Yeah.
Bye.
Bye.